Good afternoon, good morning, or good evening, wherever you may be. Thank you for attending this webinar today on Hyperconverged Infrastructure, or HCI for short. You're going to hear me use those terms interchangeably throughout the presentation, if for no other reason than to save myself syllables when talking. The title of this presentation is HCI, What, Who, and Why. I like that title because it rhymes and the agenda is right there in front of you, except for one thing. I lied about the agenda. We are going to cover the what, who, and why of HCI, but we're going to change the order up a bit. We're going to start by explaining what hyperconverged infrastructure, or HCI, is. Next, I'm going to dive into why companies are adopting this new data center architecture. And finally, we'll cover who are the market leaders and what products have emerged as the best in class for this market segment. Now, traditionally, since the dawn of virtualization, a data center has been architected with a cluster of servers, a shared storage resource, and a storage network connecting all of this together in a redundant and resilient fashion. This is known as converged infrastructure. In 2009, a company named Nutanix was founded, and in 2012, they started shipping product that introduced a new architecture design that did away with separate shared storage component and instead created a shared storage pool from the disks of the hosts participating in a cluster of hypervisors. They called this architecture hyperconverged infrastructure. It starts with a combination of 3 or more nodes. The common starting point seen here is a 2U 4-node chassis, where each node is assigned its own disks in the chassis. These nodes are independent and communicate through traditional IP networking by way of a pair of top-of-rack switches for redundancy. As more capacity is needed, additional nodes are added to the cluster, and the underlying virtualization infrastructure and applications running on top of it have no idea that the underlying architecture has changed. So Nutanix is considered to be responsible for coining the term HCI. They advocated a shift away from the 3 tiers of converged infrastructure consisting of separate compute, storage, and network hardware to unified compute, storage, and virtualization on a unified platform. VMware picked up on the HCI trend as well, and in 2014 they released their software-defined storage product called vSAN. In conjunction with vSphere, their hypervisor, vSAN is the foundation of a VMware HCI solution. Note that VMware also includes networking as a part of their HCI vision. Some people think that they may be talking about their network virtualization product, NSX. NSX is a great product and it's very complementary to vSAN, but it is not required to implement a VMware-based HCI architecture. So we've now heard a couple of different vendor definitions for HCI. Let's try to come up with our own definition for this talk today. Early on, HCI referred to a combination of servers, storage, and a hypervisor in a set of appliances. These days, the definition of HCI has expanded and been stretched by some vendors to include anything that combines servers and storage into a single manageable resource. This image is a representation of past and predicted storage growth published by the analyst firm Wikibon. You'll see this a lot when people are talking about HCI. The red segment represents the traditional shared SAN and NAS storage that people have been buying for a long time. Growth has continued and is expected to continue in this segment, but at a slower rate. The green hyperscale storage segment refers to large data center players like Google, Facebook, and Amazon, among others. If you're using a cloud service today, chances are that it's backed by hyperscale storage. Over time, HCI, or server SAN, as Wikibon calls it in this graph, is projected to overtake both of these architectures in terms of growth. But the question is why? Now, there are many reasons that people are adopting HCI, but it really comes down to one word, and that is HCI is easier. It's easier to deploy and operate because there are less specialized skills required than the traditional storage architecture. Lifecycle management is much easier due to things like firmware updates and patching being far less disruptive than they used to be. And scaling out your cluster is as simple as adding additional nodes. Of all these reasons that HCI is easier, the one that concerns people most oftentimes is scale. Do I need to scale compute and storage resources both at the same time, even if I only need one or the other? The answer is it depends. So in the image we see here, this is a slide I borrowed from Dell EMC. We see a customer in the top row purchased a hyperconverged cluster consisting of 6 nodes, and they have a few disks in each of them. To scale out in a linear fashion, the customer simply has purchased an additional node in the middle section that we see, and it has the same amount of compute and storage resources. And when the customers decided that they only need storage but not compute resources, they had the foresight to leave enough disk bays open in their cluster that they just add disks to their existing nodes. So this answers the question of being able to scale storage independently of compute. If you want to scale compute independent of storage, it's not as easy, but it is possible. Oftentimes you will be able to find nodes that have less storage, sometimes no storage, but that depends on the product that you've purchased. So yes, scaling is done according to the desires of the customer as long as they purchase the solution that meets their needs and architect it for future scaling. One reason that I would say not to adopt hyperconverged infrastructure to most customers is for CapEx savings. CapEx savings are not a reason to adopt hyperconverged infrastructure. A traditional converged architecture may consist of large upfront storage costs. Many customers purchase what they will be predicted to use for the next 3 to 5 years. So HCI can have a lower barrier to entry since most customers just buy the capacity they need for the next year or the next few quarters. But as both of these architectures grow to meet the needs of an organization, they tend to be pretty even over time. Whereas a converged architecture may see fewer large purchases over the same course of time compared to scaling an HCI solution with more frequent but smaller purchases, the end results tend to be similar. So the bottom line is that HCI is great at reducing operational costs due to decreased complexity, but capital expenditures don't tend to see major changes in the long term. So say you do decide to adopt hyperconverged infrastructure. What kind of workloads can you run on HCI? I like to answer that question with another question. What do you got? HCI has matured enough as an architecture that it provides the stability and performance required by just about any application. The important thing is to think about the kinds of workloads you will be running on your infrastructure and design a solution that meets your needs. Do you have a CPU-bound app that may require higher clock cycles or maybe more RAM? Stock your nodes full of more CPU and RAM. Is your workload bound by IOPS? You may need an all-flash cluster as opposed to a hybrid cluster consisting of spinning disks and flash media. These are the kind of design decisions that we at SIS can work on with you and help you identify the right products to meet your needs. Now I want you to notice something about this image on screen right now. Does this look familiar? I've thrown this slide into the presentation not because I think we'll have a lot of service providers attending and viewing this webinar, but to illustrate the point that no matter what the application you need to run, you can architect an HCI solution that will meet your needs. Even Nutanix has something very similar. The point is HCI is very adaptable to your organization's needs. So with that in mind, is there a case where HCI is not a good fit? There are a couple use cases I like to point out to customers. Sometimes application vendors may require platform certification, and that application may not yet be certified to run on any HCI platform. A good example of this is SAP HANA. While there are rumors that different vendors are working with SAP to get their platform certified, if you're a HANA customer today, you will likely run the application on a certified platform that is not hyperconverged to stay in compliance with SAP's best practices, if for no other reason than to avoid a battle with their support teams. Sometimes application licensing can complicate things as well. If you have a large HCI cluster and an application that you want to run requires that you license it for every CPU, socket, or core in your cluster, then you're likely to run that application on its own dedicated hardware to save on licensing costs. So the only really solid use cases we see for not running an application on HCI have more to do with logistics rather than technological limitations. With that in mind, if HCI is a good fit for nearly any application and the market is growing, which solution should you choose? Who's winning the HCI race these days? In Q4 of 2016, Nutanix had the single largest slice of the HCI pie with about 20% of the market, and Dell EMC was not far behind. Several other manufacturers have single-digit market share. Note that of the 53% others on the left-hand side of this graph, a large portion is made up of VM or vSAN nodes. Of course, since the Dell EMC merger, Dell and EMC merger, VMware is now owned by the larger Dell Technologies Corporation. If we fast forward to Q3 of 2017, the landscape looks a little bit different. Nutanix and Dell EMC have traded places in terms of revenue, with Dell taking the top spot and Nutanix in second. Note, however, that revenue from Dell's XC product line, which runs Nutanix software, is included in Dell's revenue in this table, not Nutanix's. Overall H sales in Q3 of 2017 were over $1 billion, which is 68% higher revenue than the same time a year before that. Regardless of which product you're talking about in the HCI marketplace, they're all growing. When it comes to which products are the most mature, which generate the most customer interest, and what we tend to recommend most to our customers, there are 2 or 3 main products. Dell's VxRail product is a collection of VMware software running on Dell hardware that is all bundled with Dell's VxRail Manager software to create a frictionless HCI experience and deliver a turnkey infrastructure to customers who want to focus less on the nerd knobs and get to work. Nutanix is very popular as well due to the company being the pioneer of the HCI architecture and having a very mature and feature-rich product. Some of our customers feel that neither of these are the perfect fit and will oftentimes choose to build their own HCI cluster based on VMware vSAN ready nodes. These products all share one thing in common though. VxRail is a Dell EMC product. A large portion of Nutanix's revenue is from sales of Dell's XC product line, and vSAN is a VMware solution, and VMware is owned by Dell Technologies. So the bottom line is, if you just select HCI as your architecture of choice, you most likely end up with a product from Dell in one fashion or another. So how do you choose which product to buy? These decisions depend on where you fall on what Dell EMC calls the build versus buy spectrum. I like to use a couple other terms to help visualize the spectrum: flexibility versus simplicity. Do you want the simplicity of just buying a product that you can rack and stack, turn on, quickly deploy, and then get to the business of running your workloads? Or do you want the flexibility to build based on the very hardware and software that you choose and make all the decisions about the lifecycle of that product? Decisions like that go into which product you choose when adopting HCI. Nutanix is somewhere in the middle of this spectrum. Their product takes a lot of manual processes out of your life, but gives you choice for certain things like the hardware you run their platform on, or even which hypervisor you use. Much of their architecture is pretty much the same as every other HCI manufacturer in that they have a virtual machine on each node in the cluster with direct access to the disks or controllers. These VMs communicate with each other and present their storage as a single unified pool back to the hypervisors, which see them as a single storage resource. In VMware terms, this would be a data store. Now, I mentioned that pretty much every HCI product uses this architecture. The one notable exception is VMware's vSAN. It is integrated into the vSphere hypervisor, which means it runs natively in kernel space, and you do not need to wait for a VM to boot for the data store to be available. Once a hypervisor is running, it is participating in a cluster. There's no need. vCenter is required for configuration, but is not required for operation. So a lot of times customers wonder about that. Will vSAN go down if vCenter goes down? The answer is no. You'll just not be able to make configuration changes until vCenter is back up and running. Many of the features listed in this slide, such as deduplication, compression, and erasure coding, are available on the majority of HCI products. Which features are available to you will depend on a few things, like which version of the product you license. Also, in some cases, vSAN being one of them, some of these features will require that you're running a cluster consisting of all flash storage. Now, it's important to understand how data is stored in a hyperconverged infrastructure. With HCI, storage is no longer defined by large RAID sets across all disks, but instead by policies. These policies are created to define things like the number of disks data is strafed across and how many host failures can be tolerated without data loss. Multiple policies can be defined in a single cluster to give different storage characteristics to different VMs or objects. Some can have a higher mirror count, or you can choose not to mirror but instead use erasure coding, like RAID 5 or RAID 6 for certain VMs. This is referred to as Storage Policy-Based Management, or SPBM for short. And while the styles of storage can differ a bit from one product to another, they are more similar to each other than they are to the traditional RAID sets of a traditional SAN. As I mentioned earlier, some of our customers prefer to build their own HCI cluster on the hardware that they already know and love. In these cases, we will use VMware's vSAN Ready Nodes guide as a starting point in the build process. This document keeps growing, and in the case of the screenshot here is already over 290 pages, or 260 pages, excuse me. Listed in this document are server builds from just about every server manufacturer that you can think of that have been tested and validated by VMware to run vSAN. There are certain things that you can and cannot change about these builds to meet your specific needs, and we can help guide you through that process. Don't worry about the details of this slide, but I wanted to show you the scope of vSAN and the number of features that have grown. If only to drive home the fact that vSAN has matured greatly as a product. And as of last spring, April of 2017, it had reached a very mature point in its life cycle. Of all these features that have come around since the inception of vSAN 6.6, the one I'd like to talk to customers about most is the Config Assist. Config Assist will not only validate your cluster's configuration and settings, but will also simplify management by allowing you to download and update things like controller firmware and drivers to help ensure compliance with a lot of manual processes like cross-checking compatibility guides or using a separate firmware management tool. This is one of the major reasons we recommend vSphere 6.5 and vSAN 6.6 to customers who are on the build end of the spectrum that I mentioned earlier. So with the products we reviewed in mind, you need to keep in mind the HCI landscape is full of products, and if there's something of interest that wasn't discussed today, feel free to reach out to SIS and we can take a deeper dive into what separates one product from the others. We've chosen to focus today on the products that are the most mature, have generated the most interest from our customers, and that we see as the best options when adopting HCI. Ultimately, though, when choosing a hyperconverged solution, the one thing to consider is what features are being provided by the software that the HCI platform is built on. The hardware these solutions run on is all very similar, and the main differentiator between these products is the software that makes these products work. Many of us have heard the quote that software is eating the world, and the HCI itself is a concept largely defined by software, and it's the development of the software that sets products apart from each other. Thank you. Keeping that in mind, please feel free to reach out to your SIS client exec, and we look forward to hearing from you. Thank you.